What, sir?
Okay, green on, chapter 3. One thing I'd like to show you guys, first of all, is a video. Uh-oh. A video. And let's see if the audio works. Quiet, please.
Hi, Savannah. The NTSB was unable to retrieve the black boxes yesterday because the plane was still smoldering, but they hope to retrieve them this morning and then fly them back to Washington for analysis. In the pre-dawn sky in Birmingham, fire and smoke as UPS cargo flight 1354 crashed and burned roughly half a mile short of the runway. The pilot and co-pilot never made it out alive. Seconds before the crash, witnesses thought they heard the engines sputtering or backfiring.
It flew like so close to our house until when we heard the bang, it like it shook the house. So it was quite terrifying.
I seen the sky lighting up orange. When I seen the plane on fire, I thought he's not going to make it. I just heard, now I know it's...
The tower reports no distress calls from the pilots. The fire that consumed the aircraft, intense.
We have not been able to get in and get the black boxes, if you will, the cockpit voice recorder, the flight data recorder.
Investigators hope those recorders will help them understand what went wrong. The plane involved was an Airbus A300 built in 2003 with just 11,000 flight hours, logged over 6,800 flights. The A300 was first built in 1972. While it generally has a good safety record, there have been dozens of incidents and accidents worldwide involving hundreds of fatalities, including the crash of American Flight 587 in New York in 2001. Among the questions for investigators, did the cargo shift on the UPS plane? A cargo ship was blamed on a cargo plane crash in Afghanistan earlier this year. And was the crew well rested? New FAA pilot rest requirements only apply to airline pilots, not cargo pilots.
Regardless of what kind of airplane you're flying, fatigue is fatigue, and the same sorts of protections need to be in place. And that includes the cargo industry.
In a statement, UPS says we place utmost importance on the safety of our employees, our customers, and the communities we serve. Investigators will also be looking closely at the cargo itself that was being carried. Did it contribute to the crash in any way? 3 years ago, a UPS crash in Dubai was blamed on a shipment of lithium batteries that overheated and caught fire in flight. So there's still many more questions this morning, far more than answers, and UPS is promising to fully cooperate with the investigation. Savannah?
All right, Tom Costello in Washington, thank you.
Okay, guys. So first of all, what was the name of the aircraft that crashed? Airbus 8300, I think. 8300. Bottom line is a big transport plane, right? And then, what are some of the theories as to why it might have crashed?
Lithium batteries overheated?
Well, that happened in the past. Cargo, yes, sir.
Cargo.
Okay, cargo shifting. What else?
Was for the pilots well rested?
Fatigued. And then the very end, which really I did not know, is that the transport industry, the UPS, your cargo industry, those pilots are judged differently than the actual airline industry. So they don't have the same rest hours. Cadet Faison, why don't you please go stand up in the back, please. So the point is, isn't that crazy that these guys who are flying just 2 people in those big planes, they don't have the same rest hours as the guys that are carrying 300 people. Yes, sir.
Oh, I was also going to say if the angle of attack could have gotten too great.
Because they were too slow, or maybe the cargo shifted. You're exactly right. Okay, everybody please open up their books to page 3435. Lesson 3, purpose and function for aircraft parts. We need to take attendance here with the... Everybody please click up. Go ahead and click your receivers and make sure we got attendance on this. All of them are working.
Anyone?
You go get yours? Push any button. Make sure everybody's good. Todd, did you get yours?
Just right.
Okay, Melusinik, you got yours.
Any button.
Any button. Okay, so we're good to go. Great job, guys. Everybody give a round of applause. Yay, work! Alrighty, so overview here. Basically, we can go through the different parts of the aircraft. You know why it flies and how it flies as far as the lift, drag, thrust, and weight. But now we're going to see how you adjust the aircraft to optimize those forces of flight. We're going to talk about what a definition of a spoiler is, or a flap, how it changes the aircraft shape to optimize the flight. Here's one of the first things that you need to know is the fuselage. Okay, the fuselage is the main body of the aircraft. Matter of fact, let's look over here at the wall. Look at all those aircrafts that I have up there on the wall. Okay, what is the weirdest looking fuselage of all those aircraft up there?
The left one. Okay. The B2.
You like the B2 there, the bat wing? That looks pretty cool. What about the Wright Flyer?
Yeah, that's the left one, yeah.
Not much of a fuselage. You realize one of the things about the Wright Flyer that is unusual, we're going to talk about all this stuff. When you deal with the other aircraft here, the rudder that controls the up and down motion, the pitch of it, is in the back of the plane. Okay? Back of the plane, back of the plane. The first Wright Flyer, it's in the front of the plane. So that was like one of the only differences in their plane versus ours. It made it more unstable. It made it very pitch sensitive is the term. But the actual front of the plane had the pitch, which is kind of unusual. So you're actually landing and pointing forward. And so also there are no flaps and there are no spoilers on here, and they had to change the direction of the bank via wing warping. All these wires connect to the wings. They warped the wings to change it. So that's the only major difference in the Wright Flyer versus the ones that we're actually studying here today. Alrighty, get ready to click here.
Clicker A.
So what I do is I click on this, and let's see, I don't have a time. Do I have a timer here? Oh, I do have a timer. I need to reset the timer. I usually do it down. But click and see. What do you think is the answer to this?
I don't know, I can't see.
You can't see?
Yeah.
What can you not see?
I can't see. CD.
Okay, so how about if I move over here? Does this help you?
Yes, sir.
Just lift it up and point it over his head. There you go.
Point over my head. Don't point at me. Point at the spaceship up there, guys. Okay, the answer is fuselage and wing. Just when we talked about the airfoil, you know, the different airfoil, for fighters, the wings are very small, but for cargo planes, the wings are very big, especially for the Airbuses. That is what we're talking about. What makes up the bulk of the airplane's weight? And the answer is the fuselage. We just went over the fuselage is the center part of all those planes. The engines are not very heavy, guys. A car, what is the heaviest part of a car?
Engine. Tires.
So I weigh 175 pounds. How much do you think the engine in a car weighs?
875 pounds.
I don't know. An engine weighs 500, 700 pounds, right? 800 pounds?
Yeah.
Well, a lot. I have no idea. A lot more than me. So I'm saying in a car, the cargo is not as heavy as the engine. But in the planes up here, the engines are much less than the fuselage. That's a good question. What is torque? What does that word mean? Yes, sir.
Twisting or rotation?
Twisting rotation. Exactly. When it says fuselage must be strong enough to withstand the torque, how much torque does a like a cargo plane who's coming in and land? Does that have a lot of torque? Not as much as a fighter, right? A fighter's gonna be turning and bombing and dropping stuff off of the plane. So the fuselage does have to withstand a lot of the movement of the entire aircraft. Same thing for wings. In general, all the fuel is contained in the wings. And these are kind of some new parts that you need to learn. You need to know what a wing flap is. And maybe a wing spar, S-P-A-R, is the structural part of the wing. All the wings have a skin on the top of it. But in general, all of the fuel is stored in the wings. If you look at some of these planes up here, like the B-2, look how skinny the B-2 is. All those wings have fuel in it. Look at the C-47 there on the Berlin airlift in the middle. If you're carrying cargo in the fuselage, there's no other place to put the fuel than in the wings. And actually, the air refueling planes, which we don't have a picture here, air refueling planes, they have huge tanks in the cargo which transfer the fuels out to the planes they're refueling. Wing size. How does the wing size affect the weight, guys? Yes, sir.
If it's a really light plane, it doesn't have to have big of wings.
Exactly. So then you have a lot more weight. Your wings have to get bigger, right? And so how about a glider? Why does a glider have big wings then? Yes, sir.
The bigger the wing, the more lift you have.
Bigger wing, more lift. Does anybody here do gliding? You ever glided? We actually had some glider pilots in our cadets years back. The longer the lift, the longer the wings, the more the lift. A glider needs big wings because there's no engine. And the actual lift is your thrust, and you have the uplift of the air that you're trying to catch, like a bird, right? You go up and look at the birds that float on the currents. They have huge, long wings that make it happen. Down here at the bottom, F-16, F-15, Space Shuttle have a low aspect wing ratio. Page 39. What does aspect ratio mean? Yes, sir.
Aspect ratio is a measure of how long and wide a wheel is.
Aspect ratio. How long and wide a wing is from tip to tip. And the bottom line was the greater the aspect, the greater the glide angle. Okay? So if you have an F-16 that has a low aspect and that engine turns off, how far can it glide?
Not very far.
Like a rock. Okay? F-16 glides like a rock. It falls out of the sky. But if you have a high aspect wing, like a glider, it glides forever. And so when you're flying, especially a single seat, single engine plane like a Cessna, I flew a lot of Cessnas, or an F-16, you do need to know the glide angle. So if your engine turns off, can you make the airport? Can you make a field? When you're flying in a Cessna, civilian airplane, down there at the bottom of that page, actually bottom of page 39, I don't know if you can see that there, that actual picture is your glide ratio for that plane. And you need to know that if I'm 10,000 feet high or 2 miles high, how far can you glide? And they will tell you in your owner's manual. You may be able to glide basically, say, 4 miles for every mile you're high. So maybe if you're 2 miles high, you can glide 8 miles. That helps you land or pick out a road or a field to land in if your engine turns off. Okay, wing angles, page 40. Dihedral. What about the big Airbus that crashed? What kind of angles on the wings do you think the big planes would have? What'd you say? Dihedral. Good job, listening. Yep, dihedral, because you care about being level and stable. You don't want your customers to drop their drop their coffee cups when you're flying. But when you're in a highly maneuverable plane, a fighter, an F-15, F-16, you're going to have an anhedral angle because you're going to be very, very maneuverable, and basically you're unstable. You're unstable because you don't care about keeping everything smooth and gentle because you're going to be flying upside downwards a lot. I mean, I don't know. I don't think I ever flew one mission in the F-15 that you didn't go upside downwards because you're trying to engage other planes or drop bombs. So those are basic wing angles with that. Airfoil camber. What does camber mean? Cadet level. What does camber mean? We learned that last lesson. Camber. Camber is curve. Remember, camber's curve. You were talking about chord. Okay, chord. That's okay. That's okay. So therefore, the aircraft camber, which is on the picture up here, is the curve of the airfoil, which gives you the low pressure on the top. All righty, everybody pick up the clickers. I think I did this one, not right? Where is your center of gravity? Where would that be on the plane? Between the wings, the center of gravity, the fuselage can go up and down. And that's kind of confusing because there's a center of weight and there's also a center of gravity. So I was not clear on that. But you need to know the center of gravity always is somewhere in the wing tips, because guess what? The wings have fuel in it. It's heavy, right? And it's going to be between those 2 points. We talked about this. What are the wings' main internal parts? You guys think these are the similar type questions that might be on a test?
Yes.
Maybe. Don't want to give anything away. What is a spar? We talked about that. What's a spar, guys?
It's one of the structural points.
Exactly. So I bet you the answer is either A, B, or C, right? Because it has to be a spar. Spar, ribs, and stringers.
There's 54.
Sheet metal is not necessary, right? Some stuff is made without sheet metal. Depends. I mean, some of them are made of titanium. Okay.
Okay, let's do this.
All right. We talked about wing aspects. In general, when you go faster, what happens to lift? It increases. So if I fly, I don't know, the fighters generally land around 170, 180 is the, a little less than 200. You're going to break my foot. So the normal speed is like 400, so 350 to 450. So these planes fly a lot faster than the normal planes. We talked about induced drag. Let's see, that was actually on the winglet. taking your chance. How lucky do you feel?
I feel good.
I feel good.
I feel good.
That face.
Bam.
All right, good job. Hoorah!
Yes.
Maybe give us a grade for the whole class for that, right?
Yeah. Did everyone get it right?
14, almost. Did I tell you guys, if y'all ever answer these questions and the entire class gets it right, that I stand up and do a jig and turn around and dance?
What?
And oh, by the way, last year I think I did it twice, right? It's kind of scary, right? It's kind of scary of me doing this. All righty. We talked about the airfoils. We went over this. The fact that your camber, your core, does affect the actual moving air. You have more lift if you have concave lower surfaces. Parts of the aircraft. You need to know this to graduate from this class, just like the forces of lift. Go to page 45. You need to know the different flight movement that an aircraft can have. Everybody hold their hand out. If you move the aircraft up, what's that called?
Up.
Up. No, it's called pitch. Up. If you move it up, what is it called? Up. Okay, all right. Okay, so if we sit there and move our hand up, that is called pitch. Okay, pitch. If we move our hand like this, what is that called? Roll. And what if we go left and right? It's called yaw.
Yaw.
And there are flight control surfaces.
Pitch.
Roll. Yaw. They're flight control surfaces that control every one of those. Look on our picture here behind my head. Oops, I got black behind my head. Okay. When you see something called a rudder, a rudder, put your hand up, Mr. Cody, because you can't keep your mouth shut. Here we go, Mr. Rhodey. Now, what does the rudder do? What movement of the aircraft does the rudder control?
Pitch.
What's that? Yaw. Yaw. Yay. Everybody give a round of applause.
Thank you.
Okay. Someone who I've not picked on. Cadet Val. When we talk about pitch, what controls pitch?
That would be the elevator.
Everybody give a round of applause. Amazing. Amazing. So that is right here behind us. So pitch is an elevator. Yaw is a roll. It is Friday, isn't it? Is a rudder. But what about something called? What is this? What is that called? Roll. Roll. What causes the aircraft to roll?
Trim tab.
Well, trim tab is sort of like an autopilot. We can get there. Ask him about it in a second. But the flaps, technically, are on the wings when you slow down. There is something else called an aileron. Everybody say aileron. And actually, if you look at this picture behind me, the ailerons are on the outside of the wings. Okay, ailerons. And the ailerons, if the wind is got the relative wind is coming in, and this goes up, okay, if this flight control surface goes up, what's going to happen to this wing? It goes down, and the aircraft will rotate this way. So if the relative wind comes up here, and this aileron goes down, so there's more drag on the bottom, what's going to happen to this aircraft, this wing? It'll go up. And so it's kind of opposite of what you think. Yes, sir.
All right, so I remember when we were flying the plane, or when we got to fly the plane.
You went on one of my flights? Okay.
Yeah, I remember how when we turned or rolled, Like, it always went opposite. If this went up, this went down.
You're exactly right. The ailerons go opposite.
What happens if one of them just like stayed still and one went down or up?
That is called split ailerons. It never happens in a Cessna. It has happened in fighters. I've had one of those happen. It's an emergency. You just come home, land.
Does it hurt?
It's called what you have simulators for. You hope that doesn't happen to you, 'cause that's kind of a bad day. All righty, guys, we have 1 minute for you guys to take out a piece of paper and write down A through J. That's going to take more than 1 minute.
We have G.
You may use your book. These answers are right there in your book. Why don't you do this with your shoulder partners? Look on page 45 and 44. Shoulder partners, I'll give you 2 minutes. Starting now.
Alright, so.
Okay,
A through what?
Got it? Y'all see it?
That don't use. All right.
what's that word you said?
You got 20 seconds.
Sir, what's that word?
Aileron. A-I-L-E-R-O-N is on the outside of the wings. What's the ones on the inside of the wings? Flaps. Flaps. You're going to cover all this good. Okay, 3, 2, 1, stop. Now let's look at the answers. What is A, guys? Ding. Yes. What's B?
Rudder.
Rudder. What's C?
Elevator.
What's D?
Horizontal stabilizer.
Ooh, that's tricky, tricky, tricky. What's the difference between a C and a D?
The letters, sir.
The letters. The difference between a horizontal stabilizer and an elevator. What is the difference there? That's tricky. This is advanced. Yes, sir.
Elevators move, sir.
What now?
Horizontal stabilizer stabilizes the plane from rolling, and an elevator causes the pitch to go up and down.
Basically close, but not quite. Basically, the C is a small thing of the D. Okay? And look at it. The D does not move, and the C does. So that's basically what you said. It stabilizes it. The horizontal stabilizer. Look at the A and the B. What's the difference between the A and the B besides the letter there, Cody? The rudder moves, right?
The rudder moves.
Okay. All right, E. What's E? Flaps. Great. What's F?
Air.
Excellent. G.
Spoiler.
G.
Spoiler.
Wing. Slats.
G. Wing. Wing. I. It's a French word.
Engine.
I is fuselage. No.
No.
Yeah. Fuselage.
Monsieur, comment se dit fuselage? It's French. Fuselage. Everybody say fuselage.
Fuselage.
You just spoke French. That's great. How about J? What is a J?
What's I, sir?
Oh, I'm sorry. What did I say? H? H is an engine, right? I is fuselage. What's J?
Sir.
J.
H was engine.
H is engine.
I is fuselage.
And J is a slat. Okay, we're going to go over that. A slat changes the airfoil of it. Alrighty, excellent. Everybody pull out the clicker. Let's finish up with a clicker and we will be up to propulsion. We did this one. Next. All right, quiet, quiet, quiet. Maybe I should turn on some Jimmy Buffett while y'all do this.
Yes, sir.
Dihedral is the big cargo planes, the big planes where people are drinking coffee.
Oh, shoot.
Roll straight.
Maybe I should work to get this screen over there so you can see it. Would that help out a little bit?
Yes, sir.
Or maybe, maybe should I slide to the left? Yes, great job.
Oh, I didn't get the answer.
But I slide over here. How about that? Is that better for some of you guys? Can you guys see? You guys can.
Yeah.
Yeah.
Yes,
Yes, sir, is the answer. Point to the.
That's the first one, of course.
All righty, of course. Okay, what's the answer to this?
I got it from my mom. Damn.
We went through this.
Oh.
Don't move. We got a couple more questions.
Oh man. I think I got it right. I didn't even click it.
We talked about this. Which can move?
That one's easy.
Stabilizers don't move, right? So
That wouldn't be why they're called stabilizers.
that would be why they're called stabilizers, right? Hey, I almost had to do a jig. I almost had to dance.
Really, guys?
I can dance.
Don't miss this.
I have no idea.
You got it?
Yeah. Very upset. I don't know.
Almost, guys. I'm challenging you guys to make me dance.
Come on, guys, don't miss this one.
Got it.
This, I haven't covered this. You guys will be incredibly smart if you do this.
So why'd you do that to us?
All right, we'll see.
Damn!
Oh, I didn't
Last one.
Okay.
That's what I was thinking, but I don't know. 40 stop pressing buttons.
Does Colonel Peoples dance?
Yes, sir.
Who got it? Gee, guys, I'm sorry. Today I don't dance. Tomorrow we finish up. Tomorrow we finish up. Thank